and welcome to a new video. In this video, we're going to talk about generic coding. We're going to try to understand the concept in general, and then we are going to see how do we implement the concept using Java. Now, before I say anything, I just want to talk about my opinion about this. When it comes to generic coding, I don't really like how Java handled generic coding. C++ did it a lot better than Java. But yeah, we'll see how Java handle generic coding, and I'll tell you about why do I think C++ is a lot better. So what is generic coding? Well, those are the objectives of the video for today. We're going to talk about what is generic coding. We're going to talk about generic functions, generic classes. We're going to talk about collections a little bit because they're kind of related. And then we're going to talk about the type safety of generics. So I'm just going to go through those definitions and I'm going to try to explain them. Well, generic coding basically means, or generic programming in general, the terms itself means type to be specified later. And that basically means the data type that you are going to use will not be specified when you create the program or you're typing the program. Like when you define an integer, we define a variable as an integer, you have to tell me this variable is an integer. With generic, you don't have to tell me what is the data type. The data type will be defined later. You may ask the question, why is that important? Well, here's a list of why do we need generic coding. First of all, instead of having overloaded methods, we can replace them with one method. And instead of having multiple classes that each class is going to be responsible of handling a specific data type, we can have one class that handles all the data types. This is going to eliminate redundancy. We don't have to repeat the code again, and this is going to also implement type safety, which basically what I said. Now, let's just put this on the side and let me just explain the idea. What is generic coding? Imagine yourself processing a data, whether it's a function or whether it's a class. Like you have a data structure, and the data structure, let's say it's a type integer. It's an array of integers. Now you want to do something to that array of integers. So you write a code, you write a function or write a class to process that array. And then after that, you realize, well, what if that array wasn't an integer, it was a double? Well, if it's a double, of course, when you're going to try to use that integer, that class or function that was designed for integers, it's not going to work. Java will throw an error. So what do? Basically, you create another function or another class just to be able to handle doubles. Now, after that, you ask yourself, what if it's not doubles? What if it's a character? So I'm having an array of integers, so I need a function and a class for integers. I'm having an array of doubles, then I need a class or function for doubles, and then I'm talking about characters, and then that's basically the case here. Now, what if it's not one of primitive data types? What if it's an object that you created, and you can imagine there's millions and millions of objects? Well, if that's the case, then you need to have a function and a class for each object. Now, again, if you're going to write that down, you're going to notice yourself that you write one method or one class, you copy it, you paste it, then you just replace the data types. That's again, consider redundancy. It's just repeating the same thing, but just changing the data type. And this is where generic coding is going to be really helpful. So what do we do in generic coding? Instead of deciding that this is a class of a type integer, or this is a class of the type doubles, or this is a function that's going to process integers, or this function is going to process doubles, we basically decide that this function or this class is going to process a data type of a type T. Now, what is T? I have no idea what is T. We'll just keep it T for now. T is basically something that's going to be specified later. Right after that, after you finish the definition of that class or function, all you have to do whenever you call that function, tell the function what is T. T is an integer, T is a double, T is a character, T is a car, T is a box. And then after that, the function will be able to handle it. And that's how simple the idea here. Now, when I say how simple is the idea here, that will basically be applied to C++. But with Java, it's a lot more complicated than that. So let's start with generic functions. And what do I do here? I do have a case or scenario where I am going to try to print an array. Now, I do have, as you can see here, I think I have 3 versions of that function. It's basically public static void print array. And I'm going to pass an integer array of integers, and then I'm going to get the size of that integer, and I'm going to have a very simple smart loop, and I'm going to show the values of that integer, and that's it. Now, after that, I need to have another one to deal with characters. And then I have a third one that will deal with doubles. As you can see here in the code part at the bottom right corner, I do have the declaration for those functions, those arrays, and I had to call, this is overloading method case, same name of the method, it's just basically I'm passing different types of arguments. One time it's an array of integers, characters, or doubles, and then characters. Again, this will work perfectly fine with no problems, but again, the idea here, or the problem is here, that I have the same function repeated. If you just look at the function body here, I should compare this to this to this, they are exactly the same. The only difference between those functions is what? Here, the integer definition here, and the character here, and the double here. That's considered redundant. Now, what I can do with generic functions, I can basically create one function that will be able to handle all of them. Now, with Java, and this is extremely important, and this is one of the questions that you basically might be asked in interviews, Java basically, and I'm going to say it, and I'm really sorry for this, stinks when it comes to generic functions dealing with primitive data types. The rule is, using generics, primitive data types cannot be passed as a type parameter. What does that mean? I'm going to talk about that in a sec. Anything that is used as generic has to be convertible to an object. And primitive types are not, so basically you cannot use generic with primitive data types. And also, if you try to apply arithmetic operations, it's going to be a lot more complicated. So I want you to put those 3 points in your mind because I'm going to show them in an example. And this is again what I said at the bottom. This is why C++ is my favorite programming language, because C++ basically it's like a sandbox. You can shape it the way you want it. And it's that way because it's very, very close to the processor, and which makes it a lot easier to handle. It's not easier. You have to really have a deep understanding about how the processor works and all these kind of details. But again, when it comes to generic, C++ has a higher hand. Now, before we go there, let me show you an example of the first one when using the Eclipse. Now, we do have a generic function here. No, not this one. Let's see if... Yep. So this is the case I was talking about in a sec. Here we go. This is a print array for integers, and here's my integer. Now, I just to save some time, I typed everything down here so I don't have to redo it again. So let me just copy this. Actually, I'm going to cut it and post it here. Paste it, sorry. So as you can see here, I do have my print arrays, and then after that, let's just go ahead to the declaration of those 3 arrays. Oh, not you. I'm just going to copy this for now, and then I'm going to change it in a sec. So, double. And this is going to be a character. So I'm going to run this program. As you can see, I do have those 3 arrays. I have those. And let me just go ahead and call those functions. Do I have it here? Again, I'm a little bit lazy today. I don't want to type that much. Okay, let's just copy this. And I'm going to call those functions. Now, first of all, it's print array, so with a lowercase p. And then I'm going to have to call the three of them. Copy this, put it here, put it here. Let's change this one to be 1, this to be 2. And now I do have a case. I'm not using generic here. I'm having 3 overloaded functions to print an array. And as you can see here, I got everything printed normally. Now, the idea of generic coding is, what I'm going to do, I'm going to copy one of those. I'm going to put it down. And I am going to comment those 3 functions, because that's the whole point here. I'm trying to replace them with one function. Okay. Now, the idea here is, before the return data type, you have to come here and simply type a less than or greater than sample, and then type your data type that you're going to specify later. At this point, for example, I have no idea what I'm going to call it. You can call it type, you can call it TP. Usually C++ and in Java we call it T. So this is what's basically going to be specified later. Then after that, you're just going to have to come here and just replace that with T, because again, the data type of the T is going to be specified later. And then after that, you have to come here and replace this with T as well. Now you can see here that this is working perfectly fine. There is no errors or anything. You know what I just realized? I really don't need the size here. I actually had it because I was thinking about using for loop, and then I decided to go with a smart loop, so I really don't need it. So let's take that away. And go away. Okay, so now we can see here that we got this function and everything looks okay, but look here, it's telling me you have a problem. Now if you put the mouse here, it's going to tell you the method print array of that you receive an argument of an array of type T in the main class is not applicable to argument integer, and if I remove it here, it's going to be not applicable to type double. It's not applicable to a type character. So basically, what does that mean? You cannot use primitive data types with generic. And again, this is why it sucks. And to be honest, I looked for a reason why would Java do it that way. I couldn't find an explanation that convinced me that, yeah, there's a good reason for that. No, basically, I don't think there's a good reason for that. Again, let's go ahead. To do that, basically, I need to convert, instead of having my array to be a type integer primitive, they have to be objects. Now in Java, we do have another way to create integers, which basically type integer. Now what's the difference between this integer and the previous integer? Well, you see this 1 here and 2 here and 3 here, they're not numbers anymore. They are actually objects. Just like the car, just like the box. And if I just replace this lowercase d with uppercase d, now those numbers here are not numbers anymore, they are objects. Same thing here, this has to be actually character. And now you can see those characters are not primitive data types anymore, they are actual objects. Now you may ask the question, what is the point of actually having an integer instead of primitive data types to be an object? Well, when you declare an integer as an object integer, a lot of functionality could be added to it, so you can get more done with it. So that's basically what I had to do. I had to convert my array from integer primitive data types to an array of objects of the type integer. Now, immediately after I did that, you can see that the error was gone. And I got the results back. So here it is. This is generic coding, replacing those 3 methods with one method that will work with whatever data type you decide. Now, when I say whatever, you just have to put in your mind, by whatever I mean a non-primitive data type. And that's the first example. Now, let's keep going here. Let me show you more examples. I don't think I do have more examples. This is the print array. I'm just showing you that this part to the left, will cause an error. The other one to the right will not cause any error. Okay, here is another example. Let's see here. Okay, let's go back. Now this is going to be a little bit more complicated. My Oh, this is a class. Okay, we'll use a class as an example here because as a part of the class we have methods. I do have a class. I called it My Math, and you know what? I do have it here. Let me just go and open it using Eclipse. That makes it more sense. So let me close this one, save it, and let's. This is the generic of my class. Let me just open it and show you. I actually did it, so oh, this is another one. My bad. Yeah, this is the My Math class. I don't need this right now. I want this one here. Let's see if that's the case. Oh no, this is the solution. I'm pretty sure I did have one. Yes, here it is. So here we go. This is basically what I did. I started by creating a simple class. I called it My Math. My Math basically has two integers, primitive data types, private integers, num1 and num2. I do have a constructor where I'm going to set num1 to a number and num2 to a number using the set method. What is this? Set num. And basically I have to come here and change. Well, here is the set. Look at this. Those INs, I don't know where they come from. And again here, get. Do I have get? Yep. Let me just fix it really fast. Okay, so I think here it is again. Get and get. Okay. Let's go back here. So I got a method that has two integers. This is my constructor. I got the setters and the getters down here. And I have two functions, very simple one, add and sub. The add method basically was going to add the two numbers together, and the sub is going to actually subtract the two numbers together. Now if I go back here, I do have two integers here, n1 and 2, and 3 and 4, sorry, and then I actually I created an object, and then I called n1 and m2 methods. So let's just go ahead and run it, and you can see here, yes, 3 plus 4, let's see here. Well, this is supposed to be 8, yes, and then subtracting them will give me 4. Okay. Now, the question is, if I come here and change this to be double, immediately you'll see that I got an error. Okay, so here we go. You can see that I got an error here that's not acceptable because, again, the constructor here is designed to receive two integers, and yet I'm passing doubles, so this is not going to work. So what I need to do, let me just make sure I'm in the right place. Yep. I need to come here and create a new function, new class. What I'm going to do, I'm going to call the same thing, exactly the same thing. So I'm going to go My Math. But remember here, your type already exists, so you cannot have the same name. I'm just going to put a D here. They don't want you to do that because there's something that's similar to that one, both of the letters and stuff. So I don't care for that right now. So here it is. This is my double. What I can do here, I can copy this. And there will be a lot of change that I have to apply, but that's okay. I'm just going to have to come here and change this to be a double. Now, by the way, this is not going to work. I'm just letting you know. Control C, Control V, Control V. Let's go here. Control V, Control V, Control V, Control V. Why am I saying Control V? He didn't like. Oh, yeah, of course, because this has to be uppercase T. Now that I created this class, I just come here now and put D, and it should work, but it's not. Let's see why. Type mismatch mine to my math. Oh, here. Sorry, I forgot that I have to put D here too. Now it should work with no problems, and you can see here I got the results. So here we go. So this is basically the world before generic coding. Now, generic coding with classes is not that big a different. Let me just show you the rules. But again, as I told you, this is not going to work. All you have to do is just come here after the name of the class and decide what will be the data type. And by the way, if you're going to have multiple data types, you can do that by typing multiple of them, but basically one of them has to be called T1, for example. The other one's going to have to be called T2. Now, in this case, we're just going to go with T1. And now, look what I'm going to do. I'm going to have to come here and change this to be T. Well, let's change it to T, not T1. T. And then another T. Another T. Another T. And is there another T here? Now you can see that I'm getting a lot of errors now, which basically are fixable, but we just need to wait for a sec. Most of those errors are easy to fix, except when it comes to arithmetic. Now, you can see here he's complaining about those operations here. Now what I can do here, I'm just going to show you how to fix this. Let me just take this one away. And what I'm going to do, I'm going to copy this and put it here just to show you that I can use the same function now with no problems. So I'm going to come here and type integer, and 1, and 2. Let's take those away. And there's going to be M1, there's going to be N1, and 2. And there's going to be N1, M1. So those are just warning here, but there's no error in this side. I don't need this D anymore. I'm going to use the same class to handle doubles and integers. Now, you can see here the main problem is this part. Now, if I put the mouse here, it's going to tell you, well, the operator plus is undefined for a type of T. I don't know how to deal with something that is T. Again, I'm just telling you, C++, that's not going to be a problem. But again, I'm passing a type T here. What we can do, basically, and I do have a solution here. Let me just close all this. Just remember, this is the main area we have a problem. What we can do, first of all, you need to fix this by passing integers, not a primitive data type. That will be the first fix. Second fix here, you need to test and see if, since both of them are the same data type, you need to come and check the data type for one of them at least, because they're both the same data type, and try to figure out what kind of data type do I have here. Let me see if I can actually get this done with no problems. It's actually really long code. So I'm going to come to say if, and I'm going to say num1 dot, and I think it's get class with a lowercase l. I don't think I need those. Let's see here. No, he didn't like it. I'm just going to go ahead and put equal integer dot class. Oops, why am I here? Well, he didn't like it for some reason. Num1 get class equal integer dot class. Oh, there's an T missing here. There's something about this function that get class basically will tell you what type of class this object belongs to. And if it belongs to the integer, then I will have to update this to deal with integer classes. Cast it. And then after that, I have to have a case for a double, and so on. So again, let me just close this for now. Don't save it. Don't save it. And I'm going to go ahead and open this example here, which is exactly the same. And here we go. Well, this is basically what I said. Oh, yeah, sorry, my bad. I forgot about the this. That's what I was supposed to start with. So, so I check if num1, and I try to get what type of classes num1 is. And then I compare it with integer. And basically, if this num1 was an integer object, look what I'm going to do. First of all, I need to cast them all. So what I'm going to do, I'm going to go to get num1, which is the constructor, the getter, and I'm going to cast it to be an integer. And then I do the same thing for num2. I cast it to be an integer object. I add them together. Now the compiler will be able to cast them and get you an integer. This is just an extra step to cast it to an integer. It should give you an integer, and then after that I have to cast it back to t. I don't know if this is necessary here. Let me see if I can take it out. Yep, no, it's necessary. Same thing here. Then I checked if it's an integer. After that, I go ahead and check if it's a double. And I will say else if this num1 get class equal double class. Well, basically cast it to a double, and then cast the whole thing back to a t object. So you can see here, this is basically how we can actually add the number. Now we can see here, if you think about it really, you still have it complicated here with all those if statements. But again, for the end user basically will just have to deal with my math. But the complication is all hidden inside the function itself, which basically it's okay, it's your problem, not the user who's going to buy your code problem. This is again why I feel Java didn't do a good job when it comes to generic coding. In C++, it doesn't matter. Primitive data type, actually with primitive data type, you don't have to worry about this. It will work perfectly fine. Just add num1 to num2. But with non-primitive data type, you have to tell me exactly how you want to add them together. So in C++, kind of works the opposite, and it makes sense in my opinion, because if I tell you 5 plus 5, you will say 10. But if I say car A plus car B, you have to tell me define plus. How do you want me to add two cars together? In Java, it works the opposite. If I tell you add car 1 plus car 2, yeah, somehow I can figure that out. But if you say add 5 to 6, no, I don't know how to do that. You see the point here? And that's basically what generic classes means in general. So let me just show you here. This is basically the idea that I was talking about. If I have math integer and math for doubles, those classes, and then I can replace them with one generic class. As you can see here, just remember those arithmetic operations are not that easy or simple. And this is basically how I call them. And again, using primitive data types, integers and double will not work. Even if I come here and change this double to be a double with lowercase d, integer, just int, it will not work. Okay, so this is basically what generic classes means, and this is how it works. Now you may ask the question, why is that important? I'll tell you why is that important. Now, one of the main reasons why we study programming, because there's something comes next after learning programming called data structure and algorithms. Programming is basically created to process data structures and to create algorithms to process those data structures. That's, in my opinion, the main reason of programming. Now, algorithms is basically ideas and thoughts of methods that we use to process data. But again, data structures by itself, it basically means how are we going to organize the information stored inside the memory in an efficient way. And data structure by itself, it's a big deal. It's a really big deal. And if you should be planning to take a course of data structures one day, or at least try to read it by yourself. So let's go back here. The graph that you see here shows all the data structures available in Java and how they are related. And you can tell here that the color blue here tell you that this is an interface. Green, that basically means it's a class. And if you have a solid arrow, that's extend. If you have dots or dashed arrow, that's implementation. So you can see we have a stock, we have vectors, we have linked list, we have array list, we have queues, we have priority queues, we have array queues, we have tree sets, we have sort sets, linked hash sets, and we got sets, queues, list. all belong to collections, and this is the relationship between them. Now, everything you see in this graph is done and implemented using generic classes and generic interfaces. Why is that important? Because when you take, for example, a list, that list could be an integer, could be a double, could be characters, could be strings, could be any data type. So it makes more sense to go with generic here. Same thing with the queue, same thing with the sets, same thing with all these data types. All of them together here. That's why we use generic coding. Generic coding, if you want my opinion, was basically created for this purpose specifically. Because again, if we don't have generic, that basically means out of this graph, I would need to have, I don't know how many versions. A version for integers, a version for doubles, a version for characters, a version for strings, a version for any single type of object. For example, I can have a list of cars. Well, there is no data structure designed for cars. Well, then you have to create your own data structure for that car. Do you see what I'm saying here? But again, if I create generic code, I don't need to go through this. So what I'm going to do, I'm not going to go through this because this is a totally different story, but there is one thing that I'm going to mention here, which is the array list. Just to have an idea, what is an array list? Well, array list, as you can see, is a part of the collection framework, and the collection framework is basically that graph that you see here. It's presented in Java Util, so if you want to use it, you have to import the Java Util package. It provides us with dynamic arrays of Java. What does dynamic arrays of Java mean? Well, let's go back to the static arrays that we've been using so far. With static arrays, you have to tell me what is the size. And the size of the array, for example, 5, then it's going to be 5 until the end of the program. Dynamic arrays basically means it can extend, it can shrink through the program execution with no problems. Why is that important? Because sometimes you really don't know what is the size of the array. And if you go and choose something that's too big, you end up having wasted space. If you choose something that's too small, well, you have a problem. You don't have space to store your data. So what do? We go with dynamic arrays. Now, dynamic arrays basically will specify the size of the array to be, let's say, 5 or 10. You decide at the beginning. And let's say 10 wasn't enough. Well, really simple. The size of the array is going to be extended. Now, the mechanism of how that array size is going to be extended, this is basically very complicated and it takes a lot of time. When I say a lot of time, I'm not talking about hours or minutes. It's basically comparing to other operations in programming. But when it comes to the implementation, it's not very, very efficient compared to the static array. But again, if you think about it, well, do I have other choices? No, you don't. So you have to go with this. So it's a little bit slower. But again, it fixed the problem of the size. It can get bigger or it can shrunk. Basically, I'll tell you, for example, you start with an array that has 1,000 of values and then you lost 999. Well, here's the thing. The size of the array will shrunk. If you go static arrays, well, that space is going to be reserved, whether you have an element or 1,000 elements. But the size of the array list extends and shrinks with no problems. And well, I'm going to talk about some of the operations later, but this is basically what an array list is, and this is basically how do we create. Before we do that, let me show you an example. Do I have an example? I do think I do have an example here, and it's almost empty. Okay. So this is basically, first of all, you have to import the array list. And then you have to create an object of array list, which I call a test. And now I decided that the size is going to be 5. You can put 5,000. You can put any number you want. And let's just test dot add. And I'm going to add, let's say, the value of 10. And let's go ahead and do the same thing here. Copy it. Oops, not here. Now let's just put 5 values. So 10, 20, 30, and 40, and 50. This is me adding those values. Now, if I want to get a value back, system.out.print line, I'm just going to have to go test.get. And what is the value you want to get? Now, get is just a return so you can show it. So let's say I'll put 2. 2 basically represents the location of that element. And this is 0, this is 1, this is 2. So I'm supposed to see 30 printed on the screen. And you can see here I got 30. Now look what I'm going to do. I can do this. Test dot remove. And I'll put 2 here. Okay, so what's going to happen is going to remove this element here. Okay, if it's removed, what is it going to be replaced with? Now I'm going to give you a chance to think about that. I'm taking this out. So what's going to happen? Well, let's run it. And what do I have here? I have 40. So what just happened here? Well, here's how ArrayList works. When you remove an element, all the element that's after that element is going to basically be shifted there. So this element is going to be shifted here, this 50 is going to be shifted back there, and the size is going to be reduced. Well, let me show you here. If I go back here and type plus, and let's put a space, and put a plus here, sorry, where's that double quotation? Plus test dot size. And let me just do the same thing here. Size basically will tell you how many elements you have in that array. And you can see here I got 4 now. Okay, so let me just tell you something. If you think about it, ArrayList is a lot cooler than a regular array. And the way that the list works is really interesting. But again, this is not a data structure class, so I'm not going to talk about that. You don't have to worry about it right now. The idea here is the main idea. In addition to all, there's a lot of more functionality that you can actually use. But the idea here is very simple. The size of the array can extend. Let's see, I specified that I have 5 elements here. What if I just have 2? Well, it's not a problem. It's still going to work with no problem because I already reserved space for 2, but I'm adding another 3 elements. Well, no problem. I'm just going to extend the size. And the idea here, this is how it works. My original size of the array was 2. And then when I started to add a 3rd element, that array doesn't have a space for the 3rd element. So what's the Java compiler will do? The Java compiler will create a new array with the size of 4, double the original size. And then again, copy the elements from the previous array to the new array and delete the previous array. And now I have 4 elements. So after I added those 4 elements, I created those array with 4 elements. I copied those 3 values back to that array and this 4th value. And now that I'm trying to add another element, which basically the 5th one, and still I do have 4 sizes, 4 element size array, which is not enough. So it's going to double it to 8. And this is how it works. Now, as you keep removing elements, the size of that array will go down and down and down. And that's basically how it works. Now, you may ask the question, okay, why are you telling me this? Well, number one, this type of array that I just created, array list usually, you don't see that I specify a data type here. So basically what I can do, and you'll be surprised by this, I can come here and type A. I can come here and type Adam. I can come here and type 0.0001. And if I have an object, I can put it here, but I'm just going to go with 98, just simply that way. So you can see that I have multiple data types. That's basically how I can do it. You can have any data type, but usually it's not recommended to do it that way. You can come here and type integer. And you can see immediately I got error because, again, you're telling me that it's an integer, but what is going on here? So let's take this one away and just go back to 20. And I think I know it's still going to show me that error. Let's see if that's the case. Yep, it's still showing me the error. So I need to actually put it as integer, and now it's gone. So it has to be object. You cannot use primitive data type. And I talked about that before. So here we go. This is, again, how data structures works in Java. So let's go back here and see what is this data type safety. And I'll show you an example here. Usually we have 2 types of errors. we have what we call a compile error and we have a runtime error. A compile error basically, as you type your work, you type your code, and you try to compile it, and the compile will tell you, oh, there's an error, you have to fix it. Well, here's the thing. Those type of errors, we love them. Why? Because I'm the programmer. I'm the one who's dealing with them, so I can have a chance to fix them. But there's the runtime error, which basically the error that the user is going to be facing. Now, when an error occurs to the user, the program is going to crush to the user. The user is going to hate your program. They're going to want their money back. So if you have to choose between compile errors and runtime errors, hands down, you have to choose a compile error, because a compile error will give you a chance to fix it before you actually publish or sell your product. A runtime error, it's an error that's going to happen when the user is using your product. And here's an example. I got an array list. I passed 3 values, added 2 values, Adam, Bob, and 10. And then after that, I try to convert them to strings. So the first one worked perfectly fine. I can convert that to a string. I convert the second one to a string. But when I try to convert this third one, which is the integer, to a string, that's where the program crashed. And again, remember, those could be choices that you give the user of your program. So this is, again, something you don't want it to happen. How do we fix that? Well, basically, if you specify the data type, say this is going to be a string array list. So when you did Adam and Bob, that will work. But when you try to add 10 to it, this is basically where you got a problem, and it's not going to work. So this is basically going to produce a compile error. And remember, this one didn't produce any errors. That was acceptable. And the error was generated was basically a runtime error. So your job here is to convert that runtime error to a compile error to save your work. This will be the end of this video, and I hope I didn't make it really, really long. But generic coding is really, really cool topic. And there's another topic that's just have some sort of similarity when it comes to the pronouncing of the name, is genetic programming, which is a really, really big deal. But this is way more advanced topic. It's for basically postgraduate studies. But again, think about it. If you want, have a look, just read about it so you understand how does it work. So again, this will be the end of the video. I'll see you guys in the next video.